So far, we have learned the basic concept about databases and the concepts that we have in SQL. And in this lesson, we will take a look at database programming, or how we can use a database in application programs that we develop. Now, most database users are not going to use a query language like SQL to directly interact with the database. Instead, an application program acts as an intermediate between the user and the database. So that application will provide a certain user interface that we call as the front end, and there will be another interface that connects with the database, and we call it as the back end. So this application program acts as the intermediary between the user and the database. So the user does not have to go and directly query or access the database himself. And to further clarify this, let's take the university LMS as an example. Now, when you want to do something with the LMS, first you have to identify and authenticate yourself using maybe the email and the password that is provided to you. And once you have authenticated, this LMS application will use your identity to extract information from the database and display whatever the necessary information on a graphical user interface. And it will provide different functions that maybe you can enroll to different courses, or maybe you can check your grades to previous courses and so on. So similarly, so likewise, this LMS application acts as an intermediary between the database and the user, that is you. And most of the general purpose programming languages like Python supports accessing a database programmatically. And they allows the program to construct an SQL query as a character string, and at the runtime, they will submit this SQL query to the database and retrieve the result set into the program variables. And this is achieved using what we call as a database connector. That is a piece of software or a code that connects the application to a particular database. And most of the time, these database connectors are either built in to the programming language, or they are available as a separate library that you can add to a particular programming language. So for different programming languages, there are different database connectors, and for different database management systems. And there are a lot of examples like this Open Database Connectivity, or ODBC, is one such database connector. And then we have Java Database Connectivity, or JDBC, that is specifically for Java. And similarly, for different programming languages, there are various other database connectors developed by either third party or by the developers of the programming language themselves. Since we are interested in Python specifically, let's see how we can use MySQL with a Python program. And Python also needs a MySQL connector to access a MySQL database, and that is available as a separate library. So we can simply install that by using the command python pip, maybe pip install MySQL connector Python. And once we have installed that MySQL library, we can import it just like any other library. Import mysql.connector, and then we have to create this connection object by providing the host name, that is if you are using SAMP or AMP in your local machine, that would be localhost. Otherwise, that would be whatever the IP address where this database is hosted. And then you have to provide the username to access this database and the password. So again, if you are using SAMP, that would be root and password would be empty by default, unless you have changed them. So once you execute this line, this MySQL connector will try to connect to this MySQL database hosted in localhost using these credentials. So if you have specified them correctly, that should connect it. Otherwise, you might get an error saying maybe the username is wrong or there's no MySQL database hosted in localhost. So if everything is all right, you can use this MyDB object that we just created to execute various MySQL queries. So what we do is we get this mydb.cursor, that is another cursor object. And on this cursor, we can execute, let's say if you want to create a database, we can say execute create database my database. That is the SQL query for creating the database. And we have provided it as a string to this function execute. And similarly, you can provide any other SQL query to this execute function as a parameter, maybe something like select all from customers or any other thing. And then you have to fetch the result set as well. So you can say my cursor dot fetch all, and it will fetch whatever the result that is returned by this query from the database into a variable. Then if you want, you can even maybe for loop it and try to print each row and see what the result contains. And if you want to insert something, again, it is similar. You can use this execute function, but this time you can provide two parameters. The first one with the insert query as a string, and the second one with the values specifying that should be inserted into this query. So our SQL query says insert into customers, name, address, and values. We have used this string formatting operator, percentages, and another percentages. And we are providing our values separately since it's a more convenient approach. So we will say first value is John, that would be the name, and the address would be Highway 21. So we provide it as a tuple. And for this myCursor.execute function, we are providing the query followed by the set of values. And not only that, we have to use this mydb.commit command to make sure that they get saved. So for any query like insert or update, we have to use this mydb.commit function to permanently save the changes to the database. Otherwise, they will not get saved. Alternatively, if you want to use the pandas library, it has more convenient ways of fetching data directly to a data frame. So we can import pandas, and we can say pandas.read SQL query. There's a function called read SQL query in pandas library. And to that, we can again specify the select query here as the first parameter. And as the second parameter, we have to provide that MySQL database connection object that we created before. So that would be MyDB. And when we run this line, that would fetch the data from the database, whatever the relevant data for this query. And the pandas library will create a data frame, something like this, using those data. So if you are performing further pandas operations, that would be more convenient to just use this read SQL query function, since you directly get a data frame out of that. So you can find more information about this in the pandas documentation. And now let's look at some fundamental concepts that we have to be aware of when we are developing applications that uses databases. And these concepts are not directly related today with databases, but when we are developing something, we have to be aware of them as well. And typically, an application program includes a front end where the user interacts with, and that would be the user interface. And there would be a backend component or a backend application which communicates with the database. And sometimes we might have a middle layer which contains all the business logic. So typically we call it as a 3-tier architecture. There are 3 layers that perform different tasks and also interrelated with each other. And in the recent history, web browsers have become the de facto standard for user interfaces that for the standard interface for database applications. The reason behind that is since it runs on the web browser, it enables large number of users to access database applications from anywhere. So you don't have to install a specific software on your computer. You can just use the web browser that is available on any machine to simply access a database application. And these web browsers use a standardized syntax that we call as the hypertext markup language, or simply as HTML. So all the browsers uses that standard. So any web application that is developed using these HTML syntax will work on any other browser. And on top of that, more functionalities are built with scripting languages like JavaScript. And to achieve these user interfaces with styles and formattings, we use something called as the CSS or cascading style sheets. So these 3 together form the standard for any web application that you see or even that you use. Typically, requests from the browser are sent to a web server, and there will be a backend application that processes these requests. So for example, if you take something that everybody uses, like maybe Gmail, that is basically a web application. You simply log into the Gmail application through a web browser, and what you see on the browser is the front end. And that front end will send requests to the backend application that is on a web server somewhere on a data center. And various technologies are used to create these backend applications, like scripting languages such as PHP or Python. And then we have Java related technologies like Java servlets, Java server pages, or JSP. And then we have Microsoft .NET related technologies like Active Server Page, or simply known as ASP. So likewise, there are a lot of different technologies and programming languages used to develop these application backends. And the typical architecture would be something like this. So we will have a web browser application that the user interacts with, and that will send requests through the internet to a web application that is on a web server. And that web application will connect with a database management system to retrieve and save whatever the required information. And it will also send back whatever the data and information back to this front-end application. So this part is the application that directly interacts with the database system. Usually this front-end application does not have a direct connection with the database. So that is the responsibility of whatever the application in the backend. When we develop this kind of a application that interacts with the database management system, there are certain concepts that we use to make it more convenient to develop these kind of applications. And one of them is known as the object-relational mapping. Now, we already know about object-oriented programming, the concept of using objects to represent whatever the real life entities that we want to model. And now when we have to deal with a database, that means we will have to fetch data from the database, as we just saw a few slides ago. And using those data, we will then have to create objects in the programming language. For example, let's say maybe we are developing a learning management system, and in our application, we have a class to represent a student. So that means we will have student objects. And that means we have to fetch data from the database, let's say the students table. And for each row in the table, we have to create a separate student object in the programming language. And whenever we change something in those student objects, we have to go and save those updates back to the database as well. So we have to write separate queries for each of these. And this kind of manual conversion between objects and SQL databases is cumbersome and error prone. So to ease that, we use this object-relational mapping or ORM as a solution. It is a technology that automates this mapping between the data in our database tables and the programming language, classes, and objects. For example, the same student class can be mapped to the database table students, and we can specify which columns maps to which attributes in the object student, and the ORM will take care of the rest. So we don't have to write specific queries to retrieve those records from the table and save them back. ORM will automatically do that. It will retrieve the data from the database and convert it to whatever the relevant class objects. So we can readily use the object-oriented approach. And usually this object-relational mapping is available to popular programming languages as libraries. For Python, we have a library called SQL Alchemy, and there's another one called Django ORM. And for Java, we have Hibernate. For PHP, we have Doctrine, Eloquent, and various other different ORM libraries for other popular programming languages as well. So let's see a simple example in Django ORM, that is for Python. And when we are defining a class, let's say student, in Python, we can specify that this student class is actually in the database, and the attribute name is a char attribute where the maximum length is 100, and we have a ID attribute, which is a text field in the database, and so on. And later, when we want to create objects, we can simply say S equals student, name is Alan, and ID is 1053. And we can say s.save, and the Django ORM will automatically save this student object into the database. So that will create a new row in the students table with the ID 1053 and name Alan as their values for relevant columns. And if you want to take all the students, maybe a list of student objects, you can simply say student.objects.all, and this Django ORM will automatically fetch all the student records from the database, create student objects for each of them, and we will have a list of student objects representing all students. And similarly, you can even specify other conditions, like if you want to only retrieve the students who have maybe age greater than a certain value, you can specify where clauses and all these different things that you might want to do. For all of them, there's a certain way that you can specify using this Django ORM without you having to write single SQL query. And now we will move on to look at certain practices that we use when we are dealing with databases. And as the first thing, we will take a look at how we want to store sensitive informations like passwords in databases. Now, most of the applications that we might have to develop will require the users to authenticate themselves by asking them a username and a password. That is called as the authentication. And on a basic level, we can simply store this username and the password on the users table when they first register, and later when they are trying to log in, we can compare the whatever the provided username and the password with the values stored on the database. So that is a simple enough approach that should work. But as a practice, we never ever do that. And to understand why, let's see an example. Let's say we have this user Jenny, and we have developed an application that this user Jenny is trying to register. So she provides the username as Jenny and password as Jenny #123, and she registers to the system. And if we simply store the username and the password on the users table, that will look like this. We have the username as Jenny, and under the password column, we will store Jenny #123 as a simple text value. And let's say by some accident, a third party, a hacker, or maybe even an employee working on the organization got access to this table. And now he can simply see all the usernames in this table and their relevant passwords, because we have saved them as plain text into the table. And as we know, most of the users will use the same username and password to log into many different applications. So this user Jenny might have the same username and password used to maybe to log into her email, or maybe to log into even her social medias. And now, since this hacker or this person knows Jenny's username as well as her password, he can go into another website that maybe he knows that Jenny is on, and he can simply type this username and password, and he can log into that particular website or the system. So that means we have exposed our user's password to a third party. So that's why we should never try to save this kind of sensitive information plainly onto a database. So what we do is we always have to use a one-way cryptographic hash function. A hash function is something that converts a given plain text into some kind of random text, and we call it as the hash value. And instead of storing the plain password on the database, so now what we do is we convert this text into a hash value using a hash function, which looks like some random text. And we are going to store that value in the database as the password. And whenever the user tries to log in later, what we now have to do is we convert whatever the entered password using the same hash function into that random looking hash value. And we compare that hash value with the hash value stored in the database. If they match, that means the user has entered the same password that she has used to register. And these hash functions are many-to-one mapping. That means different passwords may generate the same hash value. So that means it's practically impossible to reverse a hash value to get the original password. So you can convert a password into a random looking hash value, but you can't convert it back into the original text. It's a one-way function. And there are popular cryptographic hash functions such as MD5, SHA1, and bcrypt that uses different algorithms to calculate this random hash value or random looking hash value, which is not actually random. If you provide the same value and hash it multiple times, it should generate the exact same value. So it is a deterministic value. So this diagram actually explains how this hashing happens. So we have a plain text password, and we give it as an input to a particular hash function like maybe MD5, and as the output we get some random looking hash text. So when you look at it, it just looks like some gibberish, maybe something like this. When we save these hash values, a typical users table would look something like this. For, let's say, for the username admin, this is the hash value for password. And for these other users, these are the hash values. So as you can see, by looking at this hash text, nobody can guess what would be the actual password. You can't convert it back. It's a one-way function. So using this approach, now the user's passwords are more secure. Even the hash function passwords are not very secure, although it's secure compared to storing plain passwords in the table. The reason is a fast CPU or a GPU can generate millions of these MD5O SHA1 hashes in 1 second. So a hacker can easily generate hash values for large number of known possible passwords. And they can compare these hash values with whatever the hash values stored in the database. So if we know that when we are registering, we have to enter, let's say, 8-character password, a hacker can simply generate list of all possible 8-character text values and generate the corresponding hash values for all possible password values and compare them with whatever the hash value stored in the table. So if there's a match, that means he can simply get the original password from his list. And this is known as a dictionary attack or a rainbow table attack. And the solution for this is not very complex. And there's a simple solution known as adding a salt. A salt is a random data or a number added to the password before it is hashed. And that is done by using this kind of approach where, let's say, there are two users, user 1 and user 2, that have the same password ABCDEF. And if we simply use a hash function for both of these user 1 and user 2, that should actually generate the same hash value. Since hash functions are deterministic, ABCDEF will and should generate the exact same hash values. But now what we are going to do is we are going to add another column to this table called salt. And for each of these users, when we are creating their row or when we are inserting this particular user to the table, we are going to add a random value to this column salt. It can be a number or it can be a string and a number. And now instead of directly hashing the password ABCDEF, what we do is we add this salt value to the end of the password. So the ABCDEF becomes ABCDEF C253 for this particular user. And then we hash this entire value and store the hash value here. So this would be the hash value of password plus the salt. And for the user 2, he has a different salt value since it's a randomly generated one for each of the users. We don't know what would be the salt. Any random number that is generated and saved to the database. And again, for him, the text that is going to hash would be ABCDEF 9D4E, since he has a different salt. And when we hash that, this user gets a different hash value. So it's a completely different hash value from the user 1, although they have the same ABCDEF password. And now what happens is if a hacker has a list of hash values and in his list there would be a hash value for ABCDEF and he will compare that with these values and there won't be a match. Since each user has a different salt, now if we want to compose a list of hash values, he will have to have a list of all possible password values, and for each of these occurrence of a single password, there can be number of different salt values. So that means he have to generate all possible salt values and their hashes as well. So that means the size of that dictionary list has to exponentially increased if we want to have all possible hash values in his list. So that becomes computationally impossible to do, or at least very hard to perform. And when the user tries to log in, all we have to do is compare this hash value for that user one with the password plus take the whatever the relevant salt from the table, take the hash of that password plus salt and compare that with the stored value in the database. So with this approach, it becomes increasingly more secure compared to storing only the hash value. So still it is not impossible to break this, but at least it makes it very difficult unless you have a very, maybe something like a supercomputer. Then we will look at another security concern that we have when we are dealing with these databases. Let's consider this simple program where we have connected to a database and we are taking the user ID as an input. So we are asking the user to enter his user ID, that is UID, and we are executing a query, select all from users, where ID is equal to this, whatever the ID provided by the user. So we convert it to a string and add it to the concat with the string here. So if the user enters the ID as 10, this would become select all from users where ID equals 10. And we are going to fetch the result. So if the user enters something like this, EMP108, the query would become select all from users where ID equals EMP108. So a pretty simple program that seems like working. But what if instead of entering the user ID, a certain user decides to enter something like this particular line as his user ID? Then our query would become, since we are adding whatever the user entered value that we assume as the user ID into this into the middle of this query here. Now this query becomes select all from users where ID equals X or 1 equals 1. And what does that mean? Our where clause has now become where ID equals X or 1 equals 1. And as you can see, 1 equals 1 is always true. For any record in the users table, this would be a satisfying condition. That means it will return all the users in the table. Or the users could have even entered something like this. And then our query becomes select all from users where ID equals X. And then there's this colon, semicolon. So that actually end the query here. And then we have another text, drop table users. So that will actually won't select anything from the users table unless there's an actual user ID with X, but it will drop the table users. That will delete the entire users table from the database. This is known as SQL injection. It is one of the most common and simple hacking techniques that was commonly used like 10-15 years ago, and it can be prevented by using simple measures. So instead of using our user input values directly in the SQL queries, we can use these string operators to separately provide whatever the value to be inserted into the query. Then Python will automatically filter this out and add whatever the quotation marks around that since it's a string. So that kind of malicious queries are not formed. We call it as parameter escaping. And additionally, we can have input validations. So if we are asking users ID, we should check whatever the entered value is a valid user ID. If we know that it has to be a number, we can simply check whether the user has entered a valid ID, valid number. or if we know that it can contains only A to C characters and numbers, you can again check that. And if it contains additional characters like quotations or semicolons, we can simply reject that and ask for another value. So that is called input validation. And by using this kind of simple measures, we can completely avoid this SQL injection attacks.